Hi everyone and welcome to Conspectus. Today's topic of discussion is sperm motility. I'm Dr. Keshav Malhotra. I'm the director of Rainbow IVF and also the director of META, which is Malhotra Embryology Training Academy. And you can get in touch with me on the email metaembryology@gmail.com. So let's begin. So whenever we think of sperm motility, I think the first thought that comes to any embryologist's mind or any clinician's mind who's doing IVF is basically that it's a race. It's a race where the fastest sperm actually goes ahead and fertilizes the egg. But that's not always the case. And throughout this series, we will pinpoint the essential factors within the sperm which are actually responsible for fertilization. Obviously, motility is one of them, and that's why we're covering it first. But throughout the series, we're going to then talk about morphology, we're going to talk about the DNA, etc. etc. So as far as motility is concerned, I think all of us should know that there are three patterns of sperm motility that exist. Progressively motile sperms, which are the ones which move in a straight line or in large circles. Non-progressive sperms, which will move in zigzag parameters or which will go up and down, small circles, etc. So any non-linear pattern of movement is classified as non-progressive. And then you have immotile sperms, which are the sperms which are basically not moving at all. Now the goal of sperm preparation is to basically concentrate all of these progressive sperms into a pellet so that they can be used for insemination. If you're lucky, this is the kind of slide that you would get post preparation. But in an IVF center, it's very common that you get images or videos like this, where very few sperms are actually moving around and the others are actually immotile. Now this is basically called as asthenozoospermia. Any point where the sperm motility falls below, or the progressive sperm motility falls below 32%, would be classified as asthenozoospermia. This is an extreme scenario where the sperms are very few in number, the ones which are motile. Rest of them, if you notice carefully, they are actually agglutinating to each other. So one of the causes for sperm asthenozoospermia could be because of agglutination or anti-sperm antibodies. In a very extreme scenario, this is the kind of picture that you would get, where you have sperms which are actually immotile, quite a lot of them. There is not even the slightest motility that you can observe. Now this is known as absolute asthenozoospermia. It is not known as necrozoospermia. Necrozoospermia is just one of the causes of absolute asthenozoospermia, and how we differentiate absolute asthenozoospermia is something that I'm going to touch upon in the next few slides. But before that, let's first try and understand the causes of asthenozoospermia. Now most of the time, asthenozoospermia can actually be attributed to sperm production defects. Could be because of varicocele, could be because of hormonal imbalances, nutritional deficiencies, it's very common. Lifestyle like smoking, like alcoholism, can also attribute to asthenozoospermia. Extreme cases or rare cases, you will actually see syndromes like Cartagena syndrome, which can be a cause of absolute asthenozoospermia. And again, one common cause which I have already told you before is the presence of anti-sperm antibodies, which can actually result in asthenozoospermia. There are multiple causes of absolute asthenozoospermia. So like I mentioned, one of them is the immotile cilia syndromes like Cartagena, where you have axonemal defects in the sperm. Necrozoospermia is another cause. Then absolute asthenozoospermia can also be caused because of enzymatic deficiencies, can be caused because of anti-sperm antibodies in an extreme scenario, can be caused because of chronic infections, especially chronic prostatitis, can be because of exposure to extremes of temperature like extreme cold, can be spermicidal in nature, and it can also be caused because of prolonged abstinence. So these are all the things that an embryologist must assess, or even a clinician who's doing semen analysis must assess. Now most of the times when you're doing ICSI and you're facing such problems, they can be reduced to a certain extent if you collect the sample 1 hour prior to ICSI, prepare it 30 minutes prior to ICSI, and if you can't see sperms or if you can't see motile sperms in the PVP, catch it from hippies. So these are certain tricks which can be applied to a sample, especially when you're doing ICSI. But if it's a scenario of absolute asthenozoospermia, it's very important that we confirm the diagnosis first. How do we confirm the diagnosis? It's only done by doing a vitality assay. Vitality is a staining procedure where you use a eosin-nigrosin based stain, and the sperms which take up the stain are actually dead, the sperms which don't take up the stain are alive. Once you have vital sperms, in some scenarios you can do HOS-ICSI if that is available in your clinic, and the newer modality which is available as of now is the use of motility enhancers like theophylline, which activate the sperm, and thus even immotile sperms, because of theophylline, can actually become motile, and it becomes very easy for the embryologist to actually pick up the sperms. But it's important to understand that in some scenarios this might not work, especially in cases of primary ciliary dyskinesia or in cases of cartilaginous. Now here, if the dyne arm is broken, then how would the sperm actually get motility even if you put theophylline in it? So it becomes very important that a vitality assay is done for all of these cases, right? Like I mentioned, a vitality assay is a staining procedure. We're using eosin-nigrosin based stains, and the sperm which takes up the stain, or the sperm which actually appears pink in color, is the one which is dead. So like the ones which you see right here. So this one is dead, and the sperm which does not take up the stain, which appears white in color, that's going to be alive. The logic behind this is basically, if the sperm membranes are intact, that means it's vital. The stain cannot actually penetrate into the sperm, and that's why it does not take up the stain, and that's why it's classified as live. Once the sperm dies, the membranes lose its permeability, and the stains can easily permeate. So this is how you can actually differentiate. And if you have a vitality of more than 58%, then by just looking at the crucial morphological parameters like the tensile strength of the tail, like the normal morphology of the head, etc., etc., you can actually do an ICSI and still get viable embryos fertilized, or you can actually fertilize the eggs and get viable embryos which are worth transferring into the female. So this was a little bit about sperm motility. I hope that you like this lecture. We're going to cover all the patterns which are of importance as far as the sperm parameters are concerned in this series. And if you have any questions regarding sperm motility, obviously this was a very brief lecture, but if you have any queries regarding sperm motility disorders or sperm motility parameters, you can get in touch with me at metaembryology@gmail.com, and I'll be happy to answer. Do look forward to the different kinds of courses that we are developing with Meta. I am very sure that they're going to be very helpful to all of you, and stay tuned for the next one. Thank you.